Hey, this is Mr. V. This is the quarter 3 exam review. I'm going to be doing the evens. So number 2 here, what plane contains point S? So we have point S right here. So all you need is 3 points to name what a plane is. So I would just say plane, and then S looks to be on this plane only right here. So there's 4 points. So I can name any 3 of those 4 points. So you could do like plane SYU. You could also do, let's see here. If we're just looking right here, you could do SYU. You could do SZU. So just any of those 3 points work. All right, so find the midpoint of the line segment with the given endpoints. So we know that this is x1, this is x2, this is y1, this is y2, and all I'm going to do is plug it in there. So I'm going to have 1 plus negative 5 over 2, and then 0 plus 10 over 2. And then this is my x coordinate, this is my y coordinate, so I just simplify from there. 1 plus negative 5 is negative 4 over 2, which is then equal to negative 2. And then 0 plus 10 is 10. So 10 over 2 is equal to 5. So my final answer would be in coordinate form of negative 2, 5. All right, so 6, find the distance between each pair. So I plotted these 2 points here. What the easiest way to do it is just make a triangle and use Pythagorean theorem. If we can here, let's see here. So I'd have to use this line here and then go up. So this distance on this side is 2, and then this distance, that would be 4 plus, that would be 10. So we know this is 10, this is 2. We don't know what the hypotenuse is. So I would just use the Pythagorean theorem, which is a squared plus b squared equals c squared. Let's label this a, this b, and this c. So I would then do 10 squared plus 2 squared is equal to c squared. So 100 plus 4 is equal to c squared. So it's 104 is equal to c squared. Then I just want to get c, so I take the square root of both of those. And the square root of 104 is 10.2. I might be off a little bit. But let's see here. Hold on a second. All right, so I immediately know what I did wrong. This isn't 10 because the bottom right here is not 10. So I'm just going to erase this right here. The bottom here, because we go to 7, this would be 11. So I miscounted. So that would mean that I would just have to rewrite this and this. And I'll just do this just to make this easier so you guys can follow along. But it's going to be 11 squared. So 11 times 11, or 11 squared, is 121. So 121 plus 4 is equal to c squared. So that would be 125 is equal to c squared, and then I want to take the square root of that to find just what c is. So then the square root of 125 is equal to 11.2, because I'm rounding to my tenths. So c is equal to 11.2, that's a bad one, units. And that's giving the distance from here to here. All right, solve for x. All right, so this is our transversal right here. And then they are corresponding angles, meaning if I took this line right here and I moved it on top of here, they're both in the top left. So they're corresponding angles, and corresponding angles are congruent. So that means they're equal to one another. I would just do 6x minus 7 is equal to 105, 16x I should say. 16x would then equal 122, and then 122 divided by 16 is equal to, I'm getting a decimal, but I'm not sure if I'm supposed to. I don't believe so. So maybe I did something wrong here. 122, it's not 122, sorry about that, it's 112. So if I have to add 7, then add 7, and so that would be 112. So 112 divided by 16 is equal to 7. So x is equal to 7. So as I just displayed, it's easy to make addition errors. So go back and find your errors. 10. All right. So this is the Mr. V rule, right? So you see a V, and then you see another V, right? That means they're vertical angles, and vertical angles are equal to one another. So I would just have x plus 66. Set that equal to the other angle, which is 60. So then x is going to equal to negative 6. All right, so now we're finding the measure of angle B. We want to find out what this angle is right here. I see that this is a straight line, and a straight line is going to be equal to 180 degrees. So B plus this angle right here, 56, is equal to 180. So I'd minus 156 on each side. B is then going to be equal to 24. So we make our degree mark there too. 124. Jeez Louise, sorry. It's early in the morning. 124. 180 minus just 56. I did 180 minus 156. So, all right. Name this angle in 4 ways. So I can measure it just angle, or I can name it angle 1. I can name it angle. I think that's an I. So just an angle I. I can name it angle JIH, or I can name it angle HIJ. So for x, so a triangle here is always going to equal 180. So all of these added up, these 3 angles have to equal 180. So I would do 47 plus 70, and then plus my third angle, which is 6x minus 9. I set that equal to 180 degrees. I combine like terms, and I get 6x plus 108, and I got that by just adding this, and then minusing the 9 is equal to 180. I'm going to minus 108 on each side, so 180 minus 108, it's me 72, so 6x is equal to 72. So then we're just going to divide by 6, and we get 12. So x is equal to 12, and it's only asking us to solve for x. So that's our answer right there. 18, area and circumference. So we want to know the area and circumference of 18. And then it says for 18, we want to use the actual value. We're not putting it in terms of pi. So the area of pi is pi r squared. And I remember that because in area, you always have to leave it in terms of squared. So that's how I remember like this equation. And then circumference is just 2 pi r. Remember that r is the radius, and that is half the diameter. So that's just 3.8 right there. So then I would do 3.8 times, I would do pi times 3.8 squared for the area, and then I would do 2 times pi times 3.8 for the circumference. So then I would do, for the area, 3.8, I would square that, and I get 14.44, and then I'll multiply that by pi, and I gotta find the pi button on this calculator. Give me 1 second. All right, so I finally found the pi button. So I multiply that by pi, and that's gonna give me 45.36459. So I'm gonna round that to the 10th, and let's see which number I'm on, 20, no, I'm on 18. So then that would be 45.4. And that would be meters squared. And then I would just do 2 times pi times 3.8. And that's going to give me 23.876. I'm going to round to the 10th, so my final answer would be 23.9. So these would be my final, and then now I got to add meters. These would be my final 2 answers. All right, find the area of each. So 20 is a triangle, so I'm going to do base times height divided by 2. So my base is, remember, it's always where this 90 degree meets. Well, that's where you find your height, and then you find your base. So I would do 11 times 3.3 divided by 2. So it's 11 times 3.3 is equal to 36.3. No, that's not. Yeah, that's right. And then divide that by 2. I'm going to get 18.2, and then I have to do kilometers squared. Check my answer key, and I am correct on that one. All right, this one's a quadrilateral, so it's still base times height. And so, just erase this. It'd be, let me find my equation. All right, so my equation for a quadrilateral is going to be base 1 plus base 2 times height over 2. So as you can see, there's 2 bases here, this one, and then our height is going to be 3. So I would just do 11 plus 11 times 3 over 2. So that would give me 22 times 3, which is 66, over 2, which is then equal to 33 yards squared. You can tell it's quadrilateral because it's got 2 sets of parallel lines. So that's a set of parallel lines, and then that's a set of parallel lines. All right, 24. This one's really easy. So this is a square. All the sides are the same, and there's 4 right triangles in the corners. So you could either do square is s squared, so one side squared, or you could just do base times height. So this would just be 11.8 times 11.8. And that's going to give me 139.2. That's my final answer right there. All right, we have a trapezoid here. Again, we have 2 bases, and we've got a height. So even though these sides aren't parallel, it's still we still have to use the B1, B2, and all that, because there are 2 bases. And that's because of this right triangle. So I'm going to do, I believe that's 1.3. That's a 3.9. So I'm going to do 1.3 plus 3.9. It's going to give me 5.2. Then I'm going to multiply that by 2, which is 10.4. And then I'm going to divide that by 2, which is 5.2. So again, if you see 2 bases like this, and you have a right angle with the height, you have all 3 of these, so just plug them in. Then we got a triangle, so I know that I got to look for the right angle. This right angle connects my height with my base. So I'm going to do 8 times 7.4, and I got to divide that by 2. So 8 times 7.4 is 59.2. I got to divide that by 2. That's going to give me 29.6. I'm going to check my answer, and I am correct. Centimeters squared. All right, so we just got to identify what kind of angles these are. Again, the Mr. V rule. I see a V there, I see a V there. That means they're vertical. So that's all I got to write, is that they're vertical. 32, they're on the same side, right? So they're on, so this is my transversal. So they're on the right side of that transversal. And then they're also on the interior. So they're same side, interior angles. All right, and then for 34, I drew it to the right here, and I gave you an equation. This is just how I would solve it. So find the other end of the line segment with the given endpoint and midpoint. So I'm given this endpoint, and then I'm given this midpoint, and I'm looking for the other endpoint. So what I need to do is I just need to plug this in. So let's just take the x's first, okay? So I would do a -7 plus x2, or just, you could just put x2 or x, divided by 2 is going to give me, right here, -9. So then I would just solve that. I'd multiply each side by 2. So -7 plus x is going to be equal to -18. Then I'd add 7 to each side, so then x is going to be equal to -12. No, not 11, 12. What did I do wrong here? -18, that'd be -11. Okay, so your first point and your final answer, you have an x and a y, so that would be -11. All right, I'm going to erase that because I don't have much room. Do the same thing for the y's. I have my first y1, which is -10, and then plus my y2 over here over 2 is going to equal -6, my midpoint. So then I would multiply each side by 2. I get -10 plus y2 is equal to -12. So then I'd add 10 to each side, and y2 is going to equal 2, a +2. No, sorry, -2. And then this is your final answer right here. So that means this endpoint right here would be these coordinates. Find the value of x. Vertical angles are congruent, or another word is equal to each other. So I would just set them equal to each other. Here's your v, here's your v. So then 74 is equal to 3x plus 2. I'm going to subtract 2 on each side, so 72 is equal to 3x. After that, divide by 72. Divided by 3 is 24, so x equals 24. And then it just says just the value of x, so that's my final answer. All right, this one. Your transversal is the blue line. That's how this angle and this angle are connected. What they're on alternate sides or opposite sides of that transversal, and they're also on the exterior. So alternate exterior angles are actually, I forgot, I gotta look it up. They are also congruent or equal to one another. So I would just do 4x is equal to 96. So then I would divide 96 divided by 4, and I would get x is equal to 24. So, moving on, last couple here. So we got to do this translation. So we're moving these points. So we're adding 3, and then we're minusing 7 on the y. So what I would do is, for each one of these points here, here, and here, I'm going to add 3 on the x, and then minus 7 on the y. So, for example, for r, I'm going to start at r, and I'm going to go 1, 2, 3, and then down 7. 1, 2, 3, 4, 5, 6, and then 7. So this point right here, that's my r prime. And I put the prime on the top there. And then I'm going to start at, I believe that's a y. No, it's an s. This is an s up here. So I'm going to go plus 3. 1, 2, 3, and then down 7. 1, 2, 3, 5, 6, 7. And that's going to be my s prime. Then same thing with t. 1, 2, 3, and then down 7 is going to be here. And that's going to be t prime. Then just connect the dots. And that's your new triangle. That's your transformation. So it just gets moved. Reflection across the x-axis. The blue line is the x-axis. So each point, I'm say, all right, this t is 2 away, so I'm going to go 2 above. So right here is my new t. S is 1, 2, 3, 4, 5. So I go 5 above the blue line. 1, 2, 3, 4, 5. And that's my S prime. And then U is 1, 2, 3, 4. So I just go up 4. 1, 2, 3, 4. And that would be U prime. Connect our dots here. And you should be good to go. As long as I did this right. Let me double check my work because it doesn't look really good, but yep, that's right. So that is good to go. And then we come to some rotations. So here are your rotation rules, right? It says rotate 180 degrees. So if I rotate 180 degrees, it would be negative x, negative y. So what I would do with that is I'd have to get the coordinates of G, H, and F. So G is negative 1, 2, 3, positive 3. And then H is negative 3, 1. And then F is 1, 1, 2, 3, 4. So if I go to my 180 rule, which is right here, it says that I need to just flip x and y, or meaning flip the signs. So G prime, H prime, and F prime. So that's going to equal a positive 3 and then a negative 3. And then H is going to equal a positive 3 and then a negative 1. And then F is going to equal a negative 1 and then a positive, and then a negative 4. So all I'm doing is flipping the signs for all these. And then I plot these points. So I would have 3, negative 3. And that would be H prime. And then, not H prime, that would be G prime. Then I would do 3, negative 1. Here, let me just do this. This will make it easier. Except for I'm not going to make it bigger. Then I got that point, and then I go to negative 1, 4. So negative 1, and then a negative 4, I should say. Right there. I know those are big points, it just makes it easier. Plot your lines, make sure everything is labeled, and then you're all done. You could also do this by turning your actual paper. So 180 is not one, but 2 turns. So you'd have to turn your paper to the left or counterclockwise twice, plot it, and find those points of this right here, and mark those down, and then return your paper back to the normal, and then plot those points, and then you have your rotation. Back to some area, same thing. We got 2 bases. They are connected by a right angle, so I'm going to do base 1 plus base 2, which would be 33.3 plus 5.3, so that's 38.6. I want to multiply that by the height, which is 9.5. It's going to be 366.7. I divide that by 2, I get 183. Well, actually, that is way too big. And the reason being is that yards and feet, I forgot to look at the whatever size they are. So this is in yards, this is in yards, so I got to convert 33.3 feet into yards. So I would do 33.3. I'm going to divide that by 3. That's going to give me 11.1 yards. So this is 11.1 yards. So then, again, I do my equation. 11.1 plus 5.3 is equal to 16.4. Multiply that by 9.5, 155.8, and divide that by 2, which is going to equal 77.9. So it'd be 77.9 yards squared. That's my final answer. And then we just got another basic parallelogram with 2 bases. Well, but what we would need to do here, again, these are in different metrics. So we need to find out how many meters are in a centimeter. And there's 100, so this would be I think it's 400, it might be 4,000, let me check. Yeah, 1 meter is 100 centimeters. So if this is 4 meters on the bottom, this would be 400 centimeters on the top. So what I would need to do here is I'm going to do, this isn't just base times height. This would have to do 400 plus 400, because I got 2 bases, and then times the height, which is 200, over 2. So it'd be 800 times 200. It's going to give me 160,000. Divide that by 2. It's going to be 80,000. So my final answer is 80,000 centimeters squared. All right, so we got to classify if these are as equilateral, isosceles, or scalene. So here what you would need to do is you would need to do the Pythagorean theorem to find all of these sides. Here, here, and here. Just to save you, so that would be a squared plus b squared plus, or is equal to c squared. So I would then, so in 42, none of these sides, this side, and this side, are all different numbers, so it would be scalene. All right, so if you have any questions about this, you need to email me. You can also stop in after school or before school by Mr. Cladis, or you can go to the math lab. All right, hope you have a good one. Thanks.